My name is Andrea Padilla. I am the Net Zero Emerging Leader intern working with BRIC Architecture. There we go. Where the firm is driven to create sustainable buildings and a sustainable culture. To provide an overview of BRIC, their main guiding principle is to build relationships and inspire communities. The firm has a total of 47 employees and primarily focuses on educational design. And through the collaborative effort of the staff, the community, and the users, BRIC strives to empower the next generation of learners through innovative and thoughtful learning environments. With regards to sustainability, BRIC recognizes their role and impact the built environment has towards energy consumption. As such, the firm has committed to participate in the 2030 challenge and take the steps needed to reach a path to net zero. But before going into the work BRIC has done, I wanted to briefly discuss why this matters in the educational setting. Green schools are necessary for three major components. These are reducing environmental cost and impact, improving occupants' health and performance, and increasing sustainability literacy. As such, or notably, the users of these spaces spend 85 to 90% of their time indoors, where factors like air quality can negatively impact their learning. By addressing these factors, the goal now is not only to produce better buildings for the environment, but more beneficial learning environments for these staff and the students. BRIC's timeline started last year when they submitted their letter of commitment to AIA. Since then, they have developed a sustainability action plan and conducted firm engagement towards their goals. The next step was to begin utilizing DDX and begin tracking progress. This is where my role begins. By collaborating with the in-house sustainability coordinator, I developed my own set of goals to accomplish. This consists of creating a simple and easy method to record project information, log all applicable projects into DDX and review results, and research performance modeling software to see which would be more beneficial to use during the design process. The recording process was done by creating a Word document template and sending it to the project managers. I also attended several helpful AIA open office hours to learn how to efficiently use this research tool. Once the project information was sent back to me, this would then be recorded into DDX. In the end, a total of 19 projects throughout various cities in Oregon were recorded: 4 elementary school, 4 middle school, 8 high school, and 3 others, and these others being health centers and a district office. 7 projects are still active, 12 are completed, 8 are new construction, and 11 are remodels. The overall results demonstrate BRIC's developing progress towards the 2030 goals. On average, the projects reach about a 45% reduction rate. However, one stands out for having an energy model and for making a larger push to a path to net zero. This project is Gardner Middle School, located in Oregon City, Oregon. The currently active project had early design discussions about their energy use goals and strategies to implement them. These strategies being energy conservation, like water, electrical, lighting, and HVAC, and renewable energy strategies, like solar. This reflects their accomplishments of dropping their initial energy use intensity from 61.78 to 13 PUI. While logging projects into DDX, I also learned 2 performance modeling software and compared them to see which would be more resourceful for the firm to use. The BRIC office, located in Portland, Oregon, was used for this analysis. Climate Studio was the first program I learned, and it provides visually compelling yearly daylight metrics like useful daylight illuminance and annual glare, as well as standard energy modeling analysis that tells you your baseline EUI and how much you save. Also included in this program are annual specific dates and times analysis, as seen on the 2 plans on the bottom left. One shows when the sun is at its highest, or the summer solstice, whereas the other shows when the sun is at its lowest, the winter solstice. Climate Studio also offers radiance renderings, which expresses how natural light factors into a space. Cove Tool is the next software I learned and offers similar metrics to Climate Studio, like annual sun exposure and spatial daylight autonomy, but also introduces new features like the COVID occupancy assessment. Unlike Climate Studio, Cove Tool uses simplified modeling features to quickly test ideas, as seen with the shoebox model for facade studies, which allows you to test different window sizes and different shapes of shading devices. Moreover, they offer in-depth energy analysis, which tells you how your building is performing, what factors are contributing to this, and potential avenues to reduce it. To draw a quick comparison between the two, based on my own observation, Climate Studio allows for more design liberty to test complex designs and offers a more interactive design analysis. On the other hand, Cove Tool generates results faster, is easier to use, and provides a more in-depth analysis of the energy use results. Also important to take into consideration is that Climate Studio is only accessible on Rhino, whereas Cove Tool can be used on various softwares. Overall, this experience was a beneficial learning process for both myself and the firm. From what we have accomplished, the firm's next steps is to continue integrating energy modeling and UI tracking in the design process, develop a method to track other aspects CDS lists in their system, like renewable energy sources, predicted gliding pattern density, and embodied carbon, and lastly, to continue maintaining progress towards the 23rd challenge. This concludes my presentation, and I just wanted to say thank you so much to both the Energy Trust of Oregon and BRIC Architecture for this amazing opportunity, and to my mentors, Izzy and Andrew, for helping me during this process. Thank you.